So, as you know, we have talked about this 45, 45, 90 and 30, 60, 90 a lot, okay? 45, 45, 90 is easy because it's an isosceles triangle. I've got an x, x rad 2 right there, okay? So that's nice. Then 30, 60, 90 is below it. I mean, just write that in. It's super simple. $30, 60, 90. Opposite the 30 is my smallest side. Opposite the 90 is double the shortest side. Opposite the 60 is x rad 3. So last night for homework, I had you guys put ones in. You know, we practiced that and we filled in a chart. We'll use this and we'll use that chart in the future. So this is all easy stuff. I'm sure you're confident and good there. Okay. We've done this type of problem before on example 1. You just find the 6 trig ratios. If anybody cares, I'm not going to do this problem due to time, but if anybody cares, the sides are 2, because obviously if my hypotenuse is 4, my short leg is 2, and my opposite 60 is 2 rad 3. The 6 ratios would be sine of 30, cosine of 30, tangent of 30, cosecant of 30, secant of 30, cotangent of 30, all that. Are you ready? I have pencils and pens to do this. I'm going to go down and I'm going to start here at example 2. I have on the board for you, of course, sine, cosine, tangent, cosecant, secant, and cotangent, all here, okay? So if I'm supposed to find secant of angle P, well, guess what? Angle P is 60. I only know the hypotenuse. The hypotenuse is 10. Hypotenuse is 10. That's normally what I say is 2x. Here's my x, and here's my x rad 3. So let's fill in the other sides. Opposite my 30 degrees, if opposite my 90 degrees is 10, what's opposite my 30 degree? 5. Which leads x rad 3, 5 rad 3, opposite my 60 degree. So secant, if you recall, is hypotenuse over adjacent. Tangent is opposite over adjacent. So secant of 60, angle P is 60. Secant of 60 is hypotenuse over adjacent. This is the adjacent side. Here's the 60 degree, adjacent is 5, 10 over 5. Reduce always, easy. Next, it asks us for tangent of P, tangent of 60 degrees. Tangent, opposite over adjacent of 60. Opposite is 5 rad 3, adjacent is 5. Simplify always when you can. Well, don't the 5s reduce and go into each other? So it's just rad 3. We're done with example 2. Example 3. Let's fill in the missing sides first. Okay. Isosceles triangle, 45, 45, 90. One leg is 12. People on Zoom, tell me. Missing sides.
the one opposite, and the side BC would be also be 12, and then the hypotenuse would be 12 rad 2.
That's exactly right. Great job. Okay, so now cosecant is hypotenuse over opposite. Cotangent is adjacent over opposite. So cosecant 45 degrees is what? I'm done with number 2 already. Okay. It doesn't matter which 45-degree angle you pick. You're going to get the same result. Hypotenuse, 12 rad 2, over opposite, 12. If I pick this lower 45 degree, hypotenuse is 12 rad 2, opposite is 12. And you simplify. Just rad 2. Cotangent 45 degrees. I'll pick the top 45 this time. Again, it's still going to be the same answer as the lower 45. Cotangent, adjacent over opposite, 12 over 12. Okay. Good. I can do example 4 now. I believe I'm going slow enough for it to be fine. Can you please find the missing sides on example 4? On your own without my help. Missing triangle sides on example 4. What'd you write for your formula to find out the 2 legs? What'd you do? You have to talk louder.
Set 10 equal to x rad 2.
Yes, 10 equals x rad 2. Practice on rationalizing the denominator. Good. In order to isolate my variable x, I'm going to divide by rad 2. Then rationalizing the denominator means that I'm going to multiply the top and the bottom by this radical. I want to get rid of the radical sign. My numerator says 10 rad 2. My denominator is rad 4, but that's 2. And then any simplifying always needs to be done. 10 divided by 2. Which means my legs are both 5 rad 2. In our 45, 45, 90 triangles, it doesn't matter which 45 degree you choose. So if I pick the top one, sine, opposite over hypotenuse, 5 rad 2 over 10 is fine. Always simplify things that are outside the square root, like the 5 and the 10 can simplify to 1/2. leaving me with the numerator as radical 2, the denominator as just 2. Secant is hypotenuse over adjacent. Hypotenuse, I'll pick the lower 45 degree. The hypotenuse is 10, the adjacent is 5 rad 2. 10 over 5 root 2. I'm going to simplify the 10 and the 5 first to make my life easier. 10 over 5 is 2 over 1. 2 divided by radical 2. Somebody tell me on Zoom what to do.
Multiply the numerator and denominator by rad 2.
Yep, because I cannot have a radical in the denominator. This is called rationalizing the denominator. 2 rad 2 over rad 4. Rad 4 reduces to 2. Simplify always when you can. Final answer, just radical 2. I want to point something out. Do you guys agree that like this angle C and angle A are complementary? I mean, they add up to 90 degrees. If the whole triangle is 180, 90 degrees is already used up. Can I then say that like angle A equals 90 degrees minus angle C? Couldn't I say that? Because they're, even though they're both 45s, if it were 30 and 60, it'd still be fine. Or that angle C is 90 degrees minus angle A, because A and C are complementary. Angles, which is 90 degrees, right? Remember that from geometry, obviously. What we're going to talk about next is we're going to go through and discuss a little bit about comparing angles. So this bottom section right here, I need lots of space. Let me see. Okay. So it's the bottom of your paper. Remember how I said that I really wanted you to print out these notes? It's for reasons like this. Because I've got sine, right? Let me do black. Sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite. Aren't those reciprocals of each other? Another way to write a reciprocal in trigonometry is to say that sine is the reciprocal 1 over cosecant, 1 divided by cosecant. Likewise, I could say that cosecant is the reciprocal of sine, 1 over sine. Cosine is adjacent over hypotenuse. And secant, as you can see over there, is hypotenuse over adjacent. They're reciprocals of each other. Stating it, cosine equals 1 divided by secant means reciprocal. Secant of theta equals 1 over cosine. That's reciprocal as well. Tangent, opposite over adjacent, same as 1 divided by cotangent of theta. Theta, you remember theta just means the angle measure. We don't know what the angle is, so we just say, oh, it's theta. That's how big it is. Cotangent Adjacent over opposite. You guys are going to have a pop quiz sometime soon where I'm just going to say, here's a triangle. Here's how long the sides are, or maybe they'll be missing sides and you have to figure that out. What's cosecant of angle L? What's cotangent of angle L? And all that, okay? So you need to have these things memorized. So now on to this, a cofunction. A cofunction is when I have two angles that are complementary and I relate the two of them. So labeling of this triangle, first off, notice how angle A has an opposite side of lowercase a. Angle B has a lowercase side of side length B. Angle C is 90, but its side opposite it is lowercase c. All right, you're gonna need a lot of space. I will format for you how to draw, but you've got to write small. So this whole section right here, I want you to write it small, please. Okay, I'm gonna go through and I'm gonna write the trig functions with A, B, and C as my sides. So I'm gonna do, and I'll write the list all the way down. The sine of angle A, the cosine of angle A, the tangent of angle A, can you see? Cotangent of angle A, secant of angle A, cosecant of angle A. All right. So I'm not writing numbers, I'm writing alphabet letters. Sine of angle A, opposite over hypotenuse. A over C, opposite over hypotenuse. Cosine of angle A, adjacent over hypotenuse. B over C. Tangent of angle A, opposite over adjacent, right? A over B. Cotangent of angle A, adjacent over opposite. Angle A, adjacent over opposite, B over A. Secant of angle A, hypotenuse over adjacent, C. Secant of angle A, C over B. Cosecant of angle A, C over A. Because secant is hypotenuse over adjacent and cosecant is hypotenuse over opposite. So I did all of angle A. I did one of the acute angles. I'm now going to do another acute angle. Angle B. All the same. Don't write too big. I have more to write over in this section, so please leave space right here. Sine of B, cosine of angle B, tangent of angle B, cotangent of angle B, secant of angle B, cosecant of angle B. Again, my answers are like letters, right? Sine of angle B, opposite over hypotenuse, B over C. Hey, sine of B is the same as cosine A. Hey, it's on purpose. It's supposed to be like that. Isn't math so cool? Cosine of B, adjacent over hypotenuse, A over C. What? So cool. Sine A and cosine B are equal. Great. Tangent of B, opposite over adjacent, B over A. Cotangent of B, adjacent over opposite, adjacent over opposite, A over B. Once again, I get to get really excited. Check this out. Tangent A and cotangent B. Same. Tangent B and cotangent A. Same. Last two, and you bet they're going to be the same. Secant, which I know to be hypotenuse over adjacent, hypotenuse over adjacent, C over A. Cosecant B, hypotenuse over opposite. Yeah. C over B. So fun, matching, matching. Cosecant A and secant B, the same value. If I put them into the calculator, like if this were a degree measure or something, they'd be the same, decimal answer. Secant and cosecant, A and B match up. So what am I trying to say here? Well, remember how angle A equals 90 minus angle B, right? And angle B equals 90 minus angle A. So this is all really good, because now I'm going to talk about the true cofunction, where the two that relate to each other. Here it is. If I have cosine of A, so let me draw a line so you know I'm kind of separating my info here. If I have cosine of A, what did it equal? What did cosine of A equal? Sine of B. So A and B are related, but remember, they're complementary angles. So I have to like say whatever this measurement is, 90 minus it is B, because they add up to 90. So I'm going to say that cosine A's value is going to be the same as sine of 90 minus whatever angle A is worth. Remember how sine and cosine are buddies with the matching right here? Which means sine of A, likewise, of course you can guess it, is going to be cosine of 90 degrees minus whatever angle A is. The two of them add up to 90 degrees. I could subtract 90 minus one and get the other. 90 minus the other, you get the first. Okay. Cotangent of A, what did it match? Oh, tangent of B. Well, angle B is 90 minus A, isn't it? Tangent 90 minus A. It'll help you to know that this 90 minus A is the value of angle B. 90 minus A, that's the value of angle B. It's the value of angle B. Okay, if you really are like, what? You guys, if I told you that this is 90 degrees and this one is 40 degrees, how are you going to figure this out? How are you going to figure out how big this lower angle is? We don't care about our right angle. What do we do? 90 minus 40. You just do that in your head because it's so easy by now, because you spent all geometry doing stuff like that. But if this is angle A and this is angle B, right? Okay. Tangent of angle A equals cotangent of 90 minus A. 90 minus angle A is the same value as angle B. Last two. So sine and cosine are buddies because they're cofunctions of each other. Cotangent and tangent. Last two. Cosecant of A is secant, and then 90 minus A. And lastly, secant of angle A is cosecant's value 90 minus A. So the two that match up, tangent and cotangent, they make complementary angles, they're cofunctions of each other. Sine and cosine, secant and cosecant. In order for me to take notes on the next page, I have to scroll down, which means I have to erase this. So it's copied, good. I went slow enough. I don't think I rushed or anything. Okay. So again, I'm gonna have the top bar up. What did I do? I erased. Okay. So cofunctions. Remember, sine matches up with everybody. No, it's just plain old sine. Cosine. Everybody says together. So it's really cosine 90 take away 43. 90 minus whatever this angle is. Sine 43, if I typed it in a calculator, would be the exact same value of cosine 47 degrees. Because 90 minus 43 is 47. So I'm going to fill in these 10 values. Cotangent, its cofunction buddy is what? Hopefully you know that that's easy. 90 minus 71. Tangent of 19 degrees. Now, obviously, you guys don't have the cotangent button on your calculator. You don't have a cosecant button on your calculator, okay? So that's just how it is. But cosine, 27 degrees. Well, what's 90 minus 27? Sine. Are you guys getting what's happening? Those of you at home on Zoom, I don't know what's going on because I can't hear you. No one's. 63 degrees. They're up here too. They match, like secant and cosecant, cotangent, tangent. So I'm going to press pause on the video and I want you guys to fill them in without my help. So out loud, cosecant of 80 degrees is what? Someone. Secant of 10. Zoom, hello. Let's go quick. Tangent of 38 degrees. Cofunction is?
Cotangent of 52.
Tangent of 52 degrees. Thank you. If you volunteered already, take a break from volunteering. New people. Sine of 30 degrees. You don't say sin, you say sine.
Cosine 60 degrees.
Thank you. And likewise, a cosine of 30 is the same as a what of what?
Sine of 60.
Good. Sine of 45 degrees is the same as what? You're just subtracting.
Cosine of 45.
Cosine of 45. Tangent of 45 degrees is the same as?
Cotangent 45.
Okay, you've already helped. New people. New people. Thank you. Secant of 60. Is what?
Cosecant 30.
Thank you. Okay. Example 2. I am given cosine of theta, which means I don't know what angle, but cosine means adjacent over hypotenuse. So here's my triangle. Here will be theta. I know that the adjacent side to my theta, adjacent, which means this one, right next to it, is 24 long. I know that my hypotenuse of theta is 25. Here's the triangle, its hypotenuse is 25. This is a Pythagorean triple. The Pythagorean triple is 7, 24, 25. So this is review. The remaining values, we don't have to do cosine theta. I already know what that is. They told me. This is like review. It's think easy, easy stuff. Adjacent over hypotenuse. The angle though that I'm using doesn't have a degree measure, it's theta. Opposite over hypotenuse, sine. Opposite over hypotenuse, 7 over 25. Tangent, opposite over adjacent. Opposite over adjacent. 7 over 24. Cosecant. Hypotenuse over opposite. 25 over 7. Cosecant theta, 25 over 7. Secant of theta. Hypotenuse over adjacent. 25 over 24. Cotangent, adjacent over opposite. 24 is adjacent. Opposite theta is 7. Let me stop the recording.